Hey guys, hope you're all doing okay. This is Mr. A, and I am kind of recording these just ahead of time so you guys have notes and you guys can kind of hear me and go through things like normal. I will not be there this week, but just be the great class that you always are, and I just want you to kind of get through these, and if you have any questions, just please reach out to me. You guys know my email. I'm there to help. I had a death in the family, so I'm just going to be out for the week, and I hope you guys understand that. But don't hesitate to reach out if you have questions. I think the notes will be pretty chill for today, and hopefully chill for Friday. But let's kind of get through these. So you can see here that we are on M117 S2 Systems Part 1, Day 1. Okay, there's going to be Part 1 and Part 2 today, and I'll do both in the same video. So I'll write in some stuff now, and if you guys have a question, again, just ask. So what a system of equations is, there's a lot of ways you could think about it, but systems of equations is, I don't know, let's see what I could think of. So we're looking for when two lines, which are made of equations, looking for when two lines intersect. So intersect means cross over or go through each other, okay? So again, the main idea of a systems of equations is you have two equations which make two lines, and when those lines cross, they're going to cross at a certain point. And the idea here is that when they cross, that point that they touch is going to be the solution. It's going to be the answer, okay, to these problems. So it's a system of multiple of them, and then they're going to meet at a point, hopefully. So we represent a solution to a system as an ordered pair, which again is a point. So just remember it's a point. So that's like x comma y. So that's what we're looking for. So most of our answers, I'll show you the situations where that doesn't work, but 99% of our answers are going to be a point or an ordered pair. So a solution to a systems of equation is an ordered pair. Graphically, the solution to a system of equations is the point of intersection, which I just kind of mentioned, of the two lines. So there are three different situations below. It says, can you determine the solutions to each of these systems? So down here, these are the three types of situations that you're going to see. You're going to see this one the most. This is what you're going to see the most, where you have two lines that are going to touch at a point, and then we'll talk about those two. So if two lines cross each other, the solution is where they intersect. So that's this point right here. That point is 4, 7. So I think these are pretty chill because all we're looking for is when they cross, and they cross at 4, 7. So that problem is done. Especially when you have a graph, I think that's the nicest way to do these. In part B, you have something called parallel lines. So these lines obviously don't touch. So if you want a solution for lines that don't touch, there is no solution. Because for there to be a solution, they need to touch. So that is no solution. So if they're ever parallel lines, no solution. They're not going to ever touch. In part C, you might think like, oh, why is there just a thick line here? This is really just two lines directly on top of each other. Okay, so it's identical lines. They're the same exact line. So if you were to ask, where do they intersect or touch each other? There's infinitely many times where they touch. So we like to say infinitely many solutions. Because think about it, if you're saying, hey, where do they touch? They touch here, 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 every point forever up and forever down. And you could even write this out as IMS. Infinitely many solutions. Okay, so that's kind of a cool situation. So this, the only type, there's either one solution, no solutions, or infinitely many. And then it says, how can you use the graph of a system of equations to identify the number of solutions? Well, you're either going to get one of these three things. When they touch, there's one answer. When they don't touch, there is no answer. And when they are the same line, they touch forever, there's infinitely many. Hopefully pretty chill. Okay. Lovely. That's it. Okay, page 2. So let's do these. These are actually pretty chill here. So I'll do the left, you guys can do the right. So it says identify the solution to each system. Well, this first one is we have two lines that cross each other, so we have one solution. So the solution is where they touch, and that's 0, 5. Done deal. Okay, you guys can obviously do that one over here to see where they touch. All right, this is where it gets a little tricky. So for this next part, it says numerically, we determine whether or not a point order pair is a solution to a system of equation through substitution. We've technically done this earlier this year, but it may be a little tricky. So I'm going to show you guys what to do for this. So it says use substitution to determine whether or not the ordered pair is a solution. So when you think about substitution, think about like a sports game. Think about soccer, think about basketball. It's one person switching out for another person. Okay, it's just one person switching out. So the idea for that type of problem here is that I give you two lines, two equations, right? They're in a weird form and it's kind of hard to graph, but we're going to do this without graphing. And I'm trying to ask you guys, okay, given this line and this line, is this the answer? Is this the place where they intersect each other? And so if you look at this, you're probably like, I have no clue what's even happening here. So we are going to have to do something to find that. So what I would do is this. -2 is an x, +1 is your y. We are going to replace every x with -2 and replace every y with 1. And we'll see if it makes both of these things work. Because if it is a solution, our numbers are going to come out really nicely. And I'll show you what I mean by that. So if I put x is this and y is this, and I put those in the equation, I would get 6 times -2 minus 3 times 1 equals -15. And we're going to see if this is a true statement. But look, I just put -2 in for x, 1 in for y. So this becomes -12 minus 3 equals -15. And you get -15 equals -15. That's amazing. What that tells you, since this is a true statement, -15 does equal -15, this point is on this line. But what we need to do, though, is see if this point is on this line, too, because you can't just do one. It has to be both. So I'm also going to do this part. I'm going to plug in -2 in for x, 1 for y, and see if that works. 2 times -2 plus 1 equals -3. So see, I plug -2 in here, 1 in here. And we're going to see if this works. This is -4 plus 1 equals -3. And that's -3 equals -3. Amazing, amazing, amazing. So because this is true and this is true, yes, it's a solution. Okay, you have to do it for both. You have to do it. You can't just do it for one, because just because this worked doesn't mean this is going to work. Or just because this works doesn't mean this is going to work. They both need to work. So you have to just plug this into both parts, and it will give you if it works or not. If either of these is false, you just don't do the problem. For example, if it said like 8 equals 0, that's not true, so it would be false. So maybe that happens here. I don't know. You try it out. Hopefully it works. Okay. Maybe no, it probably works. Okay. And then finally we have this part here. So it says, numerically, we can also find a solution to a system of equations by using a table of values, by finding the place where the tables have the same value at the same time. Lovely. So let's look here. So it says determine the solution to the systems of equations for each table set. So I think this is actually pretty chill, because all we're looking for is when the same point shows up. And that's right here. They both have 1, 2. Everything else is different. So your solution is 1, 2. So look for that matching one. In this case, let me just make sure there's an answer. And there's an answer here too. So you guys can find that. Okay, so this is just part 1. And just as a heads up, guys, the homework in iExcel is U1. Go to Algebra 1, you can find this. And then you could do that there. So fill out these notes, do this iExcel. That's the only homework for today. Notice we're only on part 1. So I need you guys to now go to part 2. Part 2 is very quick. Okay, there's the code if you need it. Sorry, I maybe didn't talk about that, but hopefully the sub gives it to you. Okay, so last but not least, guys, really quick, just graphing. I think we need to practice how to graph again. I know we did that last semester, but it'd be good to practice. So you could see that there's slope-intercept form, which we've done. There's point slope, which we did. Standard form, which is kind of new. And then horizontal, vertical. I think you guys will be great at those. So I'm going to kind of work up here. You do the other ones. For this first problem, it says slope-intercept form. Remember, slope-intercept form was y equals mx plus b. So this is y equals mx, but my plus b is plus 0, because there is no b at the end. Okay? And we're going to plot my y-intercept, which is 0, because there's nothing there. And then my slope, if you guys can remember this, is 2 over 1, right? Throw it over 1. Rise over run. Rise with the y's, run with from your x. So this is up 2, right 1, up 2, right 1, up 2, right 1. And yoink, we have our line. And you guys could do that here too, on this side. But just remember, positive slope is going to go up to the right, negative slope goes down to the right. So you guys got those. That's from last semester. Point slope, this is way easier than you think. Don't tweak on this one, guys. Point slope, that was y minus y1 equals mx minus x1. Remember, m is your slope, so this is my slope. And then your point is hidden in here. Remember, it's like opposite of x, opposite of y when you plug it in. So my point here is opposite of this, -5, opposite of this, +2. So look, you have your slope and you have your point. So all you gotta do is go to -5, 2. And my slope is negative, so this is going down to the right. And put it over 1 and you have your slope, -1 over 1. Down 1, right 1, down 1, right 1, down 1, right 1. And boom, we have a great, oh god, that's ugly. Okay, we have a beautiful line. Okay, so check that out. That one's not too bad, but just really look. There's a slope, opposite of this, gives you the point. Standard form, we're gonna do it two different, whatever. However you wanna do it, you could do it, but what I would always do is try to solve for y. We don't like this form. We're gonna try to get y equals, and then we could graph it really nicely. So Isaiah always tells me this in class. He always tells me move the x, divide by the y. So I'm going to -4x on both sides. So that way I get -2y equals -4x minus 8. And then I'm going to divide by everything by -2. And that gives me y equals +2x plus 4. And you guys could graph that yourself, but just as a heads up so you know that. I don't like that. That's kind of boo-boo. Okay. I'll just do that. Okay, there we go. And you can graph that out and you're all set. So guys, if you have any questions, just reach out. Again, the only homework is just to do iExcel U1. Okay, and if you have any questions, just reach out to me, and hopefully I will see you guys soon. Bye-bye.